Hey everyone, it's time to move on a little bit now. We've been looking at free body diagrams for a lot of different situations, but now what we want to do is we want to look at some maybe more complicated systems. And we're going to be looking at three different kinds of systems. The first one we'll talk about are trusses, and you're probably somewhat familiar with trusses in the roof of your house, or perhaps the trusses set up for bridges, things along those lines. Very common for construction. The thing that identifies a truss is you're going to have a system that's been put together and everybody is stationary. Okay, so we'll start off by saying that everybody is stationary. And so here's a system of trusses in here, or this is a truss system in here. And what we're interested in doing is we're going to look at the free body diagram for the truss as a whole. So we'll be looking at all of the forces external to the truss system. And then once we've identified that free body diagram, then we'll start breaking it down into its individual components. And these components in a truss are going to be two force members. All right, so you've got one external force here, there could be more, applied here at this point. So that's some force F. And then there actually are forces at these three locations as well. And they would be external to this three-member truss. So if I said here's A and B and C and D, so the truss system would be the combination of A, B, C, D. All of those would be the truss system. And then what we're going to do is we're going to have, if we have an external force at each of these 4 points, this one is being applied by some external agent. These 3 points are being applied by the pin system that's there. All right, and what we're interested in is what are the forces on each individual member. But for a truss system, those members are two force members. In other words, AB is a member, and there are forces at A and there's force at B, right? So that's a two-force system. And then BC is a member, right? That's a two-force member. And then CD, a two-force member. So for a truss system, we always are talking about two-force members, okay? Now, if I alter this system slightly, and what I'm going to do is I'm going to extend AB. So I'm still going to have a pin mechanism here, and then a pin mechanism down here. So I'll leave that as B, but then I better change that to E. And now I have a three-force member. AE is a single beam, right? That's a single member. But there's a force acting at A, there's a force acting at E, and there's a force acting at B. Okay, so that's now a three-force member. So there's more than two forces. So this would be referred to as a frame because one of the members, in this case AE, has three forces acting on it. Okay, so that's how we step from a truss to a frame. Frames will have more than two force members. There'll be 3 plus force members acting on that. Then for a machine, the only thing I have to change for the machine is I can take out the fixed support at E, right? And so now A, B, okay, there's nothing here at E, so, but we can call it ABE. Now as I pull to the right with this force F, all of this system is free to move. And once it begins to move, then it's considered a machine. Okay, so trusses and frames, no moving parts, right? But for machines, then you have a moving part. Okay, so those are the 3 different things that we're going to be analyzing here for the next few videos. All right, that's a very simple introduction, and that should get us started. If you have any questions, please leave them in the comments below. Thank you.